Hey everybody, so we're going to be working with a new kind of factoring today, and it's important you don't skip through this slide because these do now problems are actually going to tie right into how we start the notes. So go ahead and uh, pause this, show your work, okay? Because I want you to see every step because it's going to help us to kind of deconstruct how we got FOIL in order to backtrace it to our factors here, okay? So pause this, solve these with FOIL. Okay, so if you did this correctly, right, we're going to do first times first. So 2x times x would give us 2x squared. 2x times negative 5 is negative 10x. Negative 1 times x, negative 1x, and negative 1 times negative 5 is positive 5. Should it combine like terms? And it's going to give us 2x squared minus 11x plus 5. Okay, for the second one, 3x times x is 3x squared. 3x times 6 is 18x. Negative 1 times x is negative 1x, and negative 1 times 6 is negative 6. Combine like terms, should get 3x squared plus 17x minus 6. Hopefully this is starting to move a little quicker for you now that you're getting the hang of multiplying with FOIL. 5x squared, or sorry, 5x times 2x is 10x squared. 5x times 1 is 5x. 8 times 2x, 16x. And 8 times 1 is 8, combine like terms, and we get 10x squared plus 21x plus 8. All right, so hopefully you got those correct. If not, make your corrections now. Make sure you show this work here, okay, because this is going to play a big part into how we factor these trinomials that have an a value that's not a 1, okay? So these are actually the more common trinomials, all right? So it's always nice when that lead coefficient is a 1 because those are a lot easier to figure out as far as what the factors are. But honestly, more often than not, you're going to have numbers in front of your x squared. So we got to know or have a process in order to do that. So here's the title of the notes, factoring trinomials with ax squared plus bx plus c, where a is not a 1. All right. So let's get started. Let's talk about what are some of the ways we can look at a trinomial that has a lead coefficient that's not a 1, and how do we get it back to these original factors? Okay, that's the big question. All right, so we're going to start looking for patterns in this, and hopefully this becomes kind of self-evident as we go. So when we're trying to identify this pattern, let's look at our 3 problems. All right, so if we were told or asked to factor these trinomials, all right, we know that because we did the math, the FOIL to get there, we know that the negative 11x was generated from combining those two like terms of negative 10x and negative 1. We know that 17x came from 18x minus 1. And we know that the 21x was created from adding 5x and 16x. All right, so the big question is, how do we get those two values? And we'll get to that in a minute. But more importantly, what do we do once we have it broken down into the polynomial that was created before we combined like terms? And the answer to that is a process called factoring by grouping. All right, so what we're going to do is we're going to split this polynomial into two separate groups, a left side and a right side. All right, now if I was to look at just the left side, 2x squared minus 10x, what is the GCF of just the left side? And hopefully you're comfortable with GCF at this point. We know that they both have a 2 in common and they both have an x in common. So if we were to factor that out of that binomial, then what would be left would be x minus 5. If I was to factor out the right-hand side in the same way, all right, what do they both have in common? It doesn't look like they have anything in common, right? Negative 1x plus 5 doesn't seem to have anything in common. But my goal when factoring by grouping is to make this left side match the right side with that x minus 5 factor. So knowing that, what would I factor out? Well, I know I can factor out a negative 1, and if I do that, what's left inside is x minus 5, because I'm just taking a negative 1 out of both sides. All right, so the nice thing about this is now I have a new, so here I have a polynomial, right, with 4 terms. How do I know I have 4 terms? Because I have 1, 2, 3 operators, right? So if I have 3 operations, I have 4 terms. Well, now I've turned this into a polynomial, or technically a binomial, with only 2 terms, right? How do I know there's 2 terms? Because I have 1 operator. I have this guy right here, the minus sign. So if I'm looking at this as a binomial now, well, what can I factor out of the left and the right side that's the same? Well, hopefully you see that I could divide this by x minus 5, and I could divide the right side by x minus 5 because they both have that in common. So if I was to now consider x minus 5 my GCF, what's left over when I factor that out or divide it out of both terms? I have a 2x minus 1 left over. And if you take a look at your work from the do now problems, you'll see that those were in fact the 2 binomials that created the trinomial. All right, so let's try this again with the middle one. I split it in half. And if you want to pause and work ahead and check and see and make sure you're doing this right, that's a good idea. If I look at the left and say, okay, well, I know that 3x squared plus 18x has a 3x in common, then what's left over would be an x plus 6. So you can kind of look at the right side again, knowing my goal is to have an x plus 6 on the right as well. Well, it makes it a little easier to kind of figure out what you're supposed to factor out. In this case, again, I'm going to factor out a negative 1 so that I have an x plus 6 left over, just like the left side. Now, what am I going to factor out? Well, now it's easy because now I can see the pattern. I'm going to factor out an x plus 6. And when I factor that out of both the left and the right, what do I have left? I have a 3x minus 1. Okay, same thing for this last one. I can see that I have a 5x in common. What's left over is a 2x plus 1. And in order to get a 2x plus 1 on the right side, I need to factor out a positive 8. So that's going to leave me with, again, 2x plus 1. Notice the left and the right both have a 2x plus 1 in common. So that is my greatest common factor at this point. And what's left over? You guessed it, 5x plus 8, which matches the original problems that I asked you to FOIL, right? So now the big question here is, if you're following along so far, great. The big question here is, okay, well, that makes sense. Factoring by grouping makes sense, but how the heck are you supposed to get to this point? How do you know what 2 numbers got combined to give you that B value, right? How do we get to that point? And that's where the trick comes in. It's not really a trick. It's more of a mathematical derivation of how do we backtrack, right? So as we work through these, this is going to be a very long process, but the more you do it, the faster it becomes, and you can kind of mentally do some steps as you go rather than having to write them all out. All right, so here's how you factor by grouping when this A value is not a 1, okay? So the very first thing you should always do, I've said this before and I'll probably say it again, always check for a greatest common factor. Obviously, this one doesn't have it because I have an even number, an odd number, and an even number. So 2 doesn't go into 27, so I don't have any common factors. Okay. Next, this one's step 2 is kind of optional because if you're comfortable with that a plus b squared perfect square trinomial pattern, right? You know that it factors to a squared plus 2ab plus b squared. It makes life a little easier, which is why I said you should try to memorize those. If you don't, that's okay. It just means you're going to not realize till the end that you had a perfect square trinomial. All right, the third step is a crucial step. Okay, the third step is to determine what the product of a value times the c value, right? Because what we're doing is when we find those products, 2 times 70, 140, what we're really looking for, okay, we're not looking for factors of 70, we're looking for factors of 140. So we're looking for factors of 140 that are going to add up to negative 27. Okay, so if we start listing out all of our different ways to make 140, we're looking for that combination of numbers. Again, we're trying to find those two terms that we added in order to get negative 27, right? So we make our little factor tree and we try to figure out, all right, well, what makes 140 when we multiply, positive 140, but when we add them, we get a negative 27. Now, if you recognize the patterns, obviously both of these numbers need to be negative, right? Because a negative times a negative would be a positive 140, but a negative plus a negative would give us negative 27. So once we break it down, we know, okay, well, negative 20 times negative 7 is positive 140. Negative 20 and negative 7 gives us negative 27. So what we're doing is we're rewriting the polynomial. Instead of a negative 27x, we're writing what created negative 27x. It was a negative 20x and a negative 7x. Okay, so now we're just going to group because now we have a polynomial with 4 terms. We're going to split it in half. Oh, disappeared here. So let me rewrite this. 2x squared minus 20x minus 7x plus 70. Okay, so again, all we did was separate this negative 27x into what created it. So now we're going to draw our two separate sides, left side, right side, and now you're going to take the GCF of the left. In this case, it's going to be a 2x. What's left over is x minus 10. Now we want the same thing on the right. We still want an x minus 10 on the right so that we can continue to factor by greatest common factor. So in this case, I'm going to take out not a negative 7. Sorry, I am going to take out a negative 7. So that what I have left over is an x minus 10. Okay, now I think my work's going to get erased when I switch to the next level. Maybe not. Okay, so we're going to find the GCF of each group. We just did that. Left side, right side. We want to make sure that binomial term right here is the same on both sides. And it's going to erase my work again. So once we do that, we're going to factor the binomial from each group. So let me back up to my work here. And I know that I can factor out an x minus 10. And what's left over is 2x minus 7. So notice I don't have any greatest common factors left, right? There's nothing else I can factor. So this is my factored solution. Okay, we're going to be working with this for a little while. So if you need to rewatch this and kind of get a better idea, I'm on the answer key. I'm going to give you the solutions. So it's important to check your work on the answer key. If you cannot figure out how to get those solutions, then you definitely need to ask me for some help. Okay, but that's about it. That's factoring by grouping. So again, just to recap, Always check for your greatest common factor. What that does is it makes the polynomial smaller to deal with. Okay, so you're not dealing with these huge numbers when you go to multiply a and c. Look for those perfect square trinomial patterns if you're comfortable with them, because it does make life easier. Next, multiply your a times c value. And then what you're doing is you're looking for the factors that made that number, and when you add them together, give you the middle number, the b value. You're going to split that middle value into the two numbers that created it, and then you're just going to factor by grouping. All right. So that's it for today. Please make sure you ask for help if you need it. Otherwise, I'll see you next time.